Welcome to the pre-calculus notes for chapter 3.1D. We're still looking at exponents, but today we're going to graph some exponential functions. So for the first example, we're going to graph 2 to the power of x. And you can type this into Desmos and see what it does. But let's try plugging in some number. Now, when you do these, the easiest number always to start with, I think, is 0, because anything to the 0 power is just 1. But it's also good to plug in some numbers to the left and to the right to see what's happening with the graph. So if you plug in -1, having that -1 exponent is going to shift the base of 2 to the denominator, and you're going to get 1/2. So at -1, halfway, you've got a little point there, and obviously at 0, you've got a point at 1, and so then it's going to start to grow after that exponentially, is faster than a line, right? So 2 to the first power is just 2, 2 to the second power is 4, 2 to the third power is 8, and then after that it's going to go crazy up super fast, okay? So this is called exponential growth, and exponential growth is going to happen anytime your base is larger than 1, okay? All right, there is a horizontal asymptote at x equals 0. That line going this way is going to get super close, and in fact it's going to look like it might even be touching, but it will never touch, okay? Example B is going to be an example of exponential decay. Why? Because that base is 1/3. It's a fraction, okay? All right, so anything to the 0 power, so if we take 1/3 to the 0 power, it's 1. So at 0, we should have that point there at 1. But notice this graph is quickly going down. So we want to see what's happening over to the left. So we're going to plug in more negative numbers. We're going to plug in -1, and we're going to plug in -2. So 1/3 to the -1 power moves that 3 up to the numerator, and you just get 3. 1/3 to the -2nd power moves that 3 up to the numerator, and we have 3 to the second, which is 9. So at -1, we have a point at 3, and at -2, we have a point at 9. And so it's going to go, if you look at it going this direction, it's going to get really large really quickly that way. And again, another horizontal asymptote at x equals 0. That's going to get really close, but never actually touch the x equals 0, which is the x-axis. Okay? All right, now let's look at some shifts that happen once you start changing the exponent and adding or subtracting something. So here, if you add or subtract something in the exponent, that's going to give you a horizontal shift, okay, meaning it's going to move left or right. And if you add or subtract something after the main part of the expression, that's going to give you your vertical shift. And if it's -3, then it's going to go down 3. So if you had +7, it's going to go up 7. All right. And we've got a base of 1/4. That means it's going to be exponential decay. All right. So we try plugging in some different numbers and see what happens here. So if we plug in -1, that would make that -2. That's going to move the 4 up to the numerator, and then 4 squared is 16. 16 minus 3 is 13. So at -1, you're going to have a point at +13, which is going to be way off this graph. So you can see a little point there. I just guesstimated like roughly where it would be right there. So it's up, way up here, okay? Then it's going to exponential decay real fast. We obviously have a point at 0, 1, 0, 1. And if we plug a 1 into the exponent, 1 minus 1 is 0. 1/4 to the 0 power is 0. 1 minus 1 is 0. That's going to make it, anything to the 0 power is 1, and then 1 minus 3 is -2. So we should have a point at 1, -2. That's where your shift occurs. And then if we plug in a 2, 2 minus 1 is 1. 1/4 to the first power. It's going to get you a fractional answer, or if you're doing it on your calculator, it's going to get you a decimal, -2 3/4. So you're just going to approximate. So here's 2 to the right, and then down 2 3/4. So put roughly where it would be. That makes your horizontal asymptote at -3. And that's what this number right here is. So whatever this is, and if there's nothing, it's at 0. So -3 would be your horizontal asymptote is here. +4, your horizontal asymptote would be right there. So it's just going to shift up or down. All right. Example D. Okay, this one has a base of +3. That means we're going to have exponential growth. So it's going to grow really fast. We're going to have a horizontal shift of 2 to the left. And then after the main part of the expression, we have +1, which means we have a vertical shift up 1. So see the horizontal, the asymptote right here at +1. So you just kind of dash that in. And then you can plug in different numbers to see what's happening with your graph. So if you plug in a -2, -2 + 2 is 0. 3 to the 0 power is 1. 1 + 1 is 2. If you plug in a -1, -1 + 2 is just 1. So 3 to the first power is just 3. 3 + 1 is 4. If you plug in a 0, 0 + 2 is 2. So 3 squared is 9. 9 + 1 is 10. So you can see those points on there very lightly in blue. And whatever number this is, that's where your horizontal asymptote's going to be. So dash that in, and that's it.